Welcome to Study Loop.
So in this problem, what we will do first is we'll find out the mass of the solution of this 34,300 gallons of the aqueous ammonia solution. And we can do that by, as we have given the density of the ammonia solution. So we know that the density is equal to mass over volume. So we are given the volume and the density. So multiplying this density and volume, we can find um, the mass of the solution of ammonia, and we have given also 1 gallon is how much liter. So all this, just using all this, we can find out the mass of the ammonia solution. And then since the solution is 30% ammonia by mass, we can find out the mass of ammonia in the solution, and from there we can find out the number of moles of ammonia in the solution. And then we can just find out the number of moles of citric acid which is needed or required to neutralize that number of moles of ammonia. And from the number of mole of citric acid we can find the mass of citric acid. So the first step here will be to find out the mass of the aqueous ammonia solution. So the mass of the solution will be equal to uh, first okay so first we have to find out the volume of the solution in liter. So it is given as 34,300 gallon. So 34,300 times 1 gallon is 3.785 liter. So this much gallon times 1.3 3.785 liter for 1 gallon. So it will give us a value. And then and then we are given the density which is 88 point so 88 or 0.88 gram per cc, gram per cm cube. And so 1 cm cube is 1000 liter. Oh no, 1 liter is 1000 cm cube. That means we can write down it as 0.88 times 1000 gram per liter. And then from this volume and density we can find out the mass of the solution, which will be 0.88 times 1000 gram per liter times the volume in 34,300 times 3.785 liter. And then from here we will find a value of 1.14 times 10 to the power 8 grams. So this is the mass of the aqueous ammonia solution, and the percentage of ammonia is 30% by mass. So the mass of ammonia here will be 30% or 30 by 100 of this much, which is 1.14 times 10 to the power 8 um, gram. And from there we can find out a value of 3.43 times 10 to the power 7 gram. So this is the mass of the ammonia in the aqueous solution, and from there we can find out the number of mole of ammonia just by just by dividing this mass over the molar mass, which is 17.024 gram per mole. So if we divide this mass by molar mass, we'll get the number of moles of ammonia, which will be 2.02 times 10 to the power 6 mole. So this is the number of moles of ammonia which is present there. Now we are said that acid we are provided with is uh, uh, um, contains three acidic protons. That means one mole of this, or one molecule of this acid, will be able to neutralize three molecule of ammonia. That means one mole of this acid will be able to neutralize 3 mole of ammonia, and this much mole of ammonia. So now we can write down 3 mole of ammonia can be neutralized by 1 mole of the acid. That means this much mole of ammonia, 2.02 times 10 to the power 6, can be neutralized by 1 over 3 times 2.02 times 10 to the power 6 mole, which is equal to 6.72 times 10 to the power 5 mole of the citric acid. So this is the number of moles of the acid which is required to neutralize the amount of ammonia which is present in the solution. Now we know the number of mole of the citric acid. From here, as we know that the number of moles is equal to mass over molar mass, and we are here to find out the mass of the citric acid. That means mass will be number of moles times molar mass, and we have already calculated the number of moles of citric acid as 6.72 times 10 to the power 5. So this is the number of mole of citric acid, and the molar mass of citric acid is 192.12 gram per mole. And from here we can find the mass of citric acid, which is 1.29 times 10 to the power 9 gram. So this is the mass of the citric acid which is required to neutralize the spill.